Hello and welcome students. Today we will discuss about remaining part of polynomials of class ninth. Today we will start with remainder theorem. The topic remainder is not new for you guys. You have some idea about remainder that when we divide any two numbers what remainder is. But remainder theorem in terms of polynomials is if p of x and g of x are two polynomials such that degree of p of x is greater than equals to g of x and g of x is not equals to 0, then we can find polynomials q of x and r of x such that p of x equals to g of x into q of x plus r of x, where p of x is dividend in x, g of x is divisor in x, q of x is quotient in x, and r of x is remainder in x, where r of x is equals to 0 or degree of r of x less than degree of g of x. So we can say that when we divide p of x by g of x, it gives quotient as q of x and remainder as r of x. Now in this slide, let us consider we have two numbers, say 15 and 6. You know that when we divide 15 by 6, we get the quotient as 2 and remainder as 3. Do you remember that how this fact is expressed? We can also write 15 as 15 equals to 6 into 2 plus 3, isn't it? We have represented 15 as 15 equals to 6 into 2 plus 3. Now observe that our remainder is 3, which is less than the divisor 6. Okay, so in our example, 15 is our dividend, 6 is our divisor, 2 is quotient, and 3 is our remainder. So simply we can represent it as p of x equals to g of x into q of x plus r of x in terms of polynomials. Remainder theorem continued. Let p of x be any polynomial of degree greater than or equal to 1. I repeat, degree greater than or equal to 1. And let a be any real number. If p of x is divided by the linear polynomial x minus a, then the remainder is p of a. Now, let p of x be any polynomial with degree greater than or equal to 1. Suppose that when polynomial p of x is divided by x minus a, the quotient is q of x and the remainder is r of x, and it can be simply represented as p of x equals to x minus a into q of x plus r of x. We have replaced our divisor by x minus a. Since the degree of x minus a is 1 because it is a linear polynomial and the degree of linear polynomial is 1. So the degree of x minus a is 1 and the degree of r of x is less than degree of x minus a that we have understood in our previous slides. So the degree of r of x is equals to 0. This means that r of x is a constant, say r. So for every value of x, r of x is always equals to r. Therefore, we can write it as p of x equals to x minus a into q of x plus r. So for every value of x, r of x is always equals to r. Therefore, p of x equals to x minus a into q of x plus r. Now we are assuming a particular case if x is equals to a. Then this equation gives us p of a equals to a minus a into q of a plus r. We have substituted x by a. So a minus a we will get 0. So p of a is equals to r, which proves the theorem. Now let us understand the concept of remainder theorem with the help of an example. So simple example is that find the remainder when x cube minus x square plus 1 is divided by x minus 1, which is a linear polynomial. So here Assume that p of x is equals to x cube minus x square plus 1 and divisor is x minus 1. So 0 of x minus 1 is x equals to 1, right? Now substitute value of x equals to 1 in our given polynomial. So we get p of 1 equals to 1 cube minus 1 square plus 1, or simply on solving we get p of 1 equals to 1. So by remainder theorem, 1 is the remainder of this polynomial. So basically remainder theorem gives us remainder without performing actual division. Now, moving to the next topic of polynomials, it's factorization of polynomials. Factorization of polynomials can be done by using either factor theorem or by using identities. In this slide, we will discuss about factor theorem. If p of x is a polynomial of degree n is greater than 1 and a is any real number, then point number 1, x minus a is a factor of p of x if p of a equals to 0. Point number 1 says if p of a is equals to 0, then x minus a is a factor of given polynomial. Now point number 2, p of a is equals to 0, the remainder will be 0 if x minus a is a factor of p of x. Now understanding the concept of factorization of a polynomials with the help of an example. Example is, examine whether x plus 2 is a factor of 2x plus 4. Here x plus 2 is a divisor and 2x plus 4 is our dividend. So suppose p of x is equals to 2x plus 4 and divisor is x plus 2. So when we equate x plus 2 with 0, we get x is equals to minus 2. That is the 0 of our polynomial. Now substitute value of x equals to minus 2 in our given polynomial 2x plus 4. We get p of minus 2 equals to 0. Observe that here remainder is 0, and we know that if the remainder is 0, it means given polynomial, that is x plus 2, is a factor of 2x plus 4. Okay. Now factorization of polynomials by using algebraic identities. In our syllabus we have total 8 identities which helps us in factorizing polynomials. So starting with identity 1, we have x plus y to the power 2 is given by x square plus 2xy plus y square. Identity number 2, x minus y whole to the power 2 is equals to x square minus 2xy plus y square. Identity 3, x square minus y square is given by x minus y multiply x plus y. Identity 4, it's x plus a into x plus b is equals to x square plus a plus b of x plus a into b. Now moving further with the next identity, identity number 5. This identity is based on trinomials. Here we have three variables. Identity is x plus y plus z whole to the power 2 is equals to x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Now identity number 6, x plus y whole to the power 3 is equals to x cube plus y cube plus 3xy into x plus y, or we can also write it as x cube plus y cube plus 3x square y plus 3xy square. Now moving further to identity 7, x minus y whole to the power 3 is equals to x cube minus y cube minus 3xy into x minus y, or x cube minus y cube minus 3x square y plus 3xy square. Now last but not the least, identity number 8, x cube plus y cube plus z cube minus 3xyz is equals to x plus y plus z into x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Now, special case, if x plus y plus z is equals to 0. What will happen? Right hand side will get 0. So what we will get? X cube plus y cube plus z cube minus 3xyz equals to 0. Or we can also write it as x cube plus y cube plus z cube equals to 3xyz. This is a special identity of identity number 8. Okay. Thank you, and for any query you can contact me.